आज ही डाउटनट ऐप डाउनलोड करें। डाउटनट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Okay, so the given question here we have is discuss the differentiability of this function fx, greatest integer function of x plus mod of 1 minus x, where x belongs to minus 1 to 3 interval. Yeah, definitely this notation here represents the greatest integer function, right? So basically, what this question is saying that our fx is a function, right, which is having this value plus 1 minus x, which is within mod, right? Okay, we know that if a function is discontinuous, right? If the function is discontinuous, then it is also what? Non-differentiable. This we can directly say that. This is a true fact that if a function is discontinuous, then it will always be non-differentiable. But we cannot predict that if a function is continuous, then it can always be differentiable, right? This is not the necessary condition we have, but this condition is always true, that discontinuous function is always non-differentiable, right? So if I check the discontinuous function here, if I look at this, if I have this function here, suppose this is my graph for greatest integer function, right? So we know that, okay, I'll remove this line first. I'll make it again. So this will be, if our graph is like this, right? So in this case, we have different values on the x-axis. This is 1, 2, 3. This is our 1, this is our 2, this is our 3. So that's how we plot our greatest integer function, right? From 0 to 1, it is having value 0, 1 to 2, 1, and 2 to 3, it's 3. But we can also observe from this greatest integer function that x is always discontinuous at wherever x belongs to I, x belongs to I, and I here is what? I is our integral values, which are basically 1, 2, and 3. So any integral value, on the integral value, this function, greatest integer function, is always discontinuous. It means that we can say that now that x is also what? Exactly, is also discontinuous at x equals to where? As since we know that x belongs from minus 1 to 3. So minus 1 to 3, how many integral values it is having? It is having 0, 1, and 2. So on these three values, this function is always discontinuous, which says that it is also non-differentiable. Exactly. Non-differentiable at x equals to 0, 1, and 2. Right. And the other part we have here is mod of 1 minus x. Okay, so let it explain for you. If I have a graph like this, right? So this is our 1 minus x, this is 1, this is 2. So then there will be something like this, graph of 1 minus x mod. So basically this function is continuous at 1. Sorry, this function will be continuous at 1 because we know that here LHL, RHL will be same, having 0 value because x become what? 0. Similarly, this function will be continuous for all values of x, which is 0, 1, or 2. I can write it down here as 1 minus x mod is continuous. Let's write it as COTS at 0, 1, and 2, right? But this one is not differentiable at 0, 1, 2. So whenever a function is given to us in the form of fx, gx plus hx, right? So even any of the another function which is gx and hx becomes what? It become whole completely discontinuous. If gx is discontinuous or either hx is discontinuous, then the whole function will become discontinuous. Even if the other function is continuous, it will not affect the statement. So basically we know that our function here, greatest integer x, is what? Discontinuous, and this is continuous at 0, 1, and 2. But we know that eventually if any of the function is discontinuous, the whole function will become discontinuous. So we can say that fx is discontinuous basically at x equals to 0, 1, and 2, which means it is also non-differentiable at x equals to 0, 1, and 2. And this is what we have to prove about the differentiability of this function.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।